I'm Rushikesh. I'm member of technical staff at Netscope. I'm cloud security enthusiast and identifying the malwares and phishing services is my hobby. And over to you, Ashwin. Please give the context of our talk. Yeah, thank you.
Hi all, a warm welcome to you all, and I thank you all for attending this talk, and I would even thank Nalcon for hosting this conference. Nalcon is one of the most biggest podium of security conferences in India and even in the Asia, and it is one of the biggest security conferences that is noted in the world. And on the same lines, I even would like to thank you all for making this conference a huge success, and in spite of all the health parameters of news that is happening, you guys have made it to Nalcon and made it a good success. For that, I would like to thank you all. So, without taking much time, a brief introduction about me. My name is Ashwin. I have an innate interest in malwares using cloud, and wherein cloud is used as a threat actor. And I have spoken in conferences like RSA, DEF CON, B-Sides. And for more details, you can actually look into my blog and, of course, my LinkedIn profile. Now, before getting into the literal context of what we are trying to talk, I would like to give you an essence of why we are talking it, because that is very, very important for people to understand that why is this important, or why the hell are these guys actually talking this particular presentation. The biggest aspect of today's generation is cloud. We know that all the transmission is happening towards cloud. In the earlier days, you had pen drives wherein you used to use it, you used to copy back data, or you used to have some external drives and you used to use it at different places you used to go. But currently, you don't have it because you have cloud. Wherever you go, you can just log into the cloud device and download your file. And to give a simple context, the need for speed actually gives the need for cloud. That is where the cloud has come into picture. Now, we all know that most of the enterprises are also moving towards cloud. We have something like software as a service, infrastructure as a service, platform as a service. And not only that, we have even seen the traditional websites are moving from static websites to cloud. And in this context, there are bigger problems that are happening. One, evaluations. How many here use Gmail? Good. How many use storage Google APIs? Very less. So now, the protection services that are offered in Gmail, is it the same that is given in a service like storage Google APIs? No. That is the biggest problem of evaluations that people have to think about. Because in a shared context of cloud, when it transitions itself from software as a service, platform as a service, and infrastructure as a service, a biggest challenge comes into place that is called shared responsibility model, which says that what I am offering, that means what the vendor offers, and what you have to take in as a responsibility. That actually is the biggest challenge of what we have observed in our research. And the biggest other problem is, do you have enough control? Are you having enough security controls in making sure that all the threats are identified? Are you having enough security controls in understanding from where the file is coming into the enterprise? And the biggest other problem is, what is the security posture? Many people have threat protection in place. I agree to it. But do you have threat protection for all the services for the prescribed cloud vendor? You know that Google is offering a lot of services. We have something called Google Sites. We have something called Google Storage APIs. We have something called Google App Engine. Is the protection there homogeneous across all these services? That is another problem that we are trying to cover. But this is how it traditionally looks. People just take the files, put it into cloud and say, yes, we are ready, and the enterprise has moved towards cloud, or our website has moved towards cloud. And of course, many people ask, are you really sure whether you have the security posture in place? Now, this is one stage of a problem. Let's get into the next stage of the problem. Threat actors. Threat actors also say, I too need cloud, because that's the best way for me to get into an enterprise. Because the biggest point of cloud is trust. If I use the trust, I can break its crust. That's the picture, right? So threat actors have actually used this. They're actually using cloud, and we'll try to actually talk in this particular essence of why threat actors have used into cloud, and we'll be detailing in the 4 most important patterns that we have observed wherein it has used cloud. Now, the shared responsive model that I covered earlier, this is an example of telling, like, whenever you are going to have a pizza, right from an on-prem service, when it transitions itself into cloud, in the various offerings of cloud, how the controls change. So if you look into the right-hand corner, you see here configuration, functions, scaling, runtime, operating system, virtualization, hardware are the important essence for any enterprise. Okay. Now, if you look into something called the on-prem, that means the traditional enterprises wherein you had your own database, you had your own server, you had all the controls within yourself. Everything was something that you manage. But when it moves into cloud, only there are some things that you manage and there are some things that the vendor manages, and that is wherein the gap analysis comes into picture. So as you traditionally see here, the oven and electric gas is something with related to kitchen. Okay, so that was something that you can manage in something like an infrastructure as a service. Sorry, that is something that you can manage in terms of that is something that the vendor manages in terms of an infrastructure as a service. And as it actually transitions itself to container as a service, platform as a service, function as a service, and software as a service, what will happen is the transition of you managing and the vendor managing would actually have a tectonic shift. So as you see here, in a software as a service, the vendor manages everything. What you just need to do is conversation. So conversation, if you take into a context, like consider an example of Gmail. You use Gmail for sending emails. That's the only thing that you need to do. The vendor takes care of everything. He takes care of managing the load, managing the storage, etc., and so on. Of course, for personal Gmail accounts, we know that it is limited to 30 GB, but most of the controls is done by the vendor. It's only you who actually initiate a conversation. So this is how the transition takes place. Of course, this is not the essence of the talk, but this just tells the specification of why we are actually talking this particular presentation. Now, the cloud security posture. This is very important. We have done an academic research with our data and of course with the data of where people have deployed cloud. And these are some interesting observations that we have found. It was quite surprising even for us. The first important point. Only 30% of the enterprises are defending against malware. Now, if you go back to my earlier point, I've told that you have a lot of services in cloud, right? Do you have homogeneous threat protection across all cloud services? No. So only 30% of the enterprises are actually protecting against malware. Only 15% of the enterprises are reaching regulatory compliance. Regulatory compliance might be something with GDPR, etc., and so on. But as such, regulatory compliance is also important for actually storing your data and hosting your data. And this is what I was actually trying to tell. 14% of the enterprises are only securing major cloud applications that they use. For example, I use Gmail. I only protect Gmail. Am I protecting Google Groups? Am I protecting Google Sites? No. That's where threat actors are actually taking advantage. And only 10% of the users are discovering unsanctioned cloud applications in use. Just to give a context of what is sanctioned and unsanctioned. Sanctioned is something that you use it in your premises. Unsanctioned is something that is not used in your premises. And 9% of the enterprises are protecting mobile devices. You all take mobile devices, you use SSO, you use a lot of other applications that actually talk in data from your mobile devices to an enterprise cloud traffic, but only 9% of the enterprises are actually protecting you from it. And only 8% of the enterprises are preventing cloud misconfigurations. They just take in the cloud service and deploy it. They don't actually do a metrics on evaluating what are the misconfigurations that can be caused. And only 7% of the enterprises are protecting BYOD. You all know that, right? Because cloud services come into picture. There's something called public cloud and private cloud. Public cloud is something that you can log in from anywhere. And if you're logging in from a compromised device, maybe your credentials can get stolen, or maybe there can be any type of a compromise. And only 7% of the companies are doing it. Our talk is specifically looking into the highest percentage, which is 30%, wherein only 30% of the enterprises are defending against malware. And we will try to explain why it's very, very important. So now, malware in the cloud. This is what our topic is. We all have now got a picture of cloud, so let's transition our journey towards cloud. Of course, it looks like it is raining here, but it's not raining. So in this picture of cloud, what do we use cloud for predominantly? For keeping files, so that you can retrieve it whenever you want to. Of course, for hosting your infrastructure. And of course, for a cloud acting as a platform. And for this context, what does the user do? He daily interacts with the cloud for hosting files or for using the particular cloud offering, and he even retrieves it back to his own endpoint. Okay. Not only this, the whole enterprise also uses cloud, right? Now this is one part of the picture. Now in the earlier days, wherein if at all look into the team's perspective, just let me go into one part. So how many are you from the red team here? Anybody from the red team? Yeah. Blue team? Okay, so as such for me, the team's perspective is different, but something is like with all information security professionals here, we deal with something called bad. Bad is nothing but build, attack, and defend. Okay, so from a threat actor's perspective, if at all he wants to break in your network or create a compromise, he need not look into what are the vulnerabilities present in your machine, but he can target this cloud. So what he can do, just now comes the introduction of the threat actor. He just puts a malware here. And what happens is, since we use malware for the day-to-day operations, and if at all we have collaborations, we have sync, we have many other types of ways of how cloud is being used, the malware transitions itself from the user to all the people in the enterprise. This is actually why we are telling this particular presentation. Now, what's the motivation why threat actors are doing it? One, we all trust cloud. We think that if Gmail protects us from malware, all the cloud services of Google also protects us from malware. That's not the truth. Next thing, it's easy to use and abuse. Do you all know that whenever you register something called a cloud account like Azure, Amazon, and GCP, if you just validate your credit card information, you'll be given 12 months of free subscription. This is a huge time to live for a threat actor. Okay. And of course, you don't need a server, you don't need to maintain its infrastructure and all. It reduces the infrastructure overhead of the threat actors. And as such, we all know that it is way more powerful than traditional hosting or computing services. And we have seen many talks with related to detecting threat attack patterns. Let's get into the reality. If anything is suspicious in terms of the URL, like domain generation algorithm, or if it is using a bulletproof hosting server, we'll automatically block it. Okay. But if I use a trusted service, can you block it? No. You can't block drive.google.com because you use it for a day-to-day operations. Nor in the same case, you can't block a service of Google and you can disrupt its operations. Like for example, you can't take down Google service. You know that. And the biggest advantage for threat actors is it gives them protection by default, HTTPS, API-driven communication, etc. Now, let's get into the real picture. Lights, action, camera. So here it's cloud. So here, consider that a document is being shared to you. And this document is something which is predominantly needed for your day-to-day operations, and it is shared to you. Or consider one case that you have visited your company, you're a new joinee, and a particular document is there in a Google Drive folder, and you're looking into the document. So when you're looking into the document, what will happen is here, when you opened it, it's nothing malicious here. There's a shrink in and a shrink out because the document is masked in nature. So what do? I click it. So when I click it, what happens? It says that this document is trying to connect to appengine.google.com. First thing, for a tech-savvy user, what will you see? Whether it connects to a HTTPS website? Yes. Whether it's connecting to a legitimate website, which you use in your enterprise. Consider that I'm using Google in my enterprise. Yes. Appengine.google.com is a legitimate domain. So what do I think? Okay, fine. The file that is coming to me is clean. I'm going to execute this file, or I'm going to look into it. What happens in the background is, this actually abuses something called Google Open Redirection. Currently, a disclaimer is fixed by Google. So whenever, earlier times, whenever a particular file got connected to appengine.google.com and it got redirected, there was no warning attempt to a user. Currently, there's a warning displayed from Google telling like if you want to really go to that third-party website. Maybe here, Google has its protection policies in place. But if you see here, there is a string called continue, which says that it connects to a different website called transf.biz, which downloads the real malware in place. Do you have protection for it? Nobody knows. What does the user think? That it connects to google.com. That's where the biggest compromise can happen. Okay. So traditionally how this malware does is, it actually logs out from Google, and Google has something called redirectors. So it will redirect you to the company's website, or it will redirect you to a search engine optimization, or to something with related to ad analytics. So for that, Google gave a privilege to use something called continue. And what do the threat actors do? They actually abuse this particular technique. This is one. Let's look into another interesting aspect. Consider that I use Office 365 for my day-to-day operations in an enterprise. How important it is. One, when I get a website, what do I see? Whether it is connecting to a legitimate domain, whether its HTTPS certificate is valid, and whether it's related to my day-to-day operations, because it is something with related to the day-to-day operations. So now, when this particular website has come into picture, what do I first look? Whether it's connecting to a legitimate domain. HTTPS, okay, fine, it's good. Windows.net is a legitimate domain again. And what do I do next? I might think, oh, this again looks suspicious to me. Let me do this. Let me look into the certificate. If I look into the certificate of it, what does it say? It is signed by Microsoft because it is an Azure service. blob.co.windows.net is an Azure service. You can even host websites in it. And here, when it is there, what do I do now? I think that it is good because I use it in my day-to-day operations and it is something with related to my enterprise. And boom, I enter my credentials, and it is gone to the threat actor. This is why this particular presentation is in place. So now over to Rushikesh in telling the agenda of the important attack patterns that we will be trying to cover in this presentation.
Thanks, Ashwin. So in line with the malware in the cloud and the motivation of the threat actors, we are going to cover specific attack pattern with the theme malware in the cloud. And the themes are cloud as a malware hosting platform, cloud as a command and control channel, cloud as a platform to spread malware, and cloud as a platform to host crimeware as a service. While covering these themes, we are going to tell you how to protect against these cloud threats. So we are going to cover first attack pattern, which is cloud as a malware hosting platform. In this, we are going to cover first malware, which is Cloud Squirrel. It is basically info stealer malware campaign, which is written in a Java, and seeing its file details, payload, and its parameter, we found out it is targeting the Brazilian users. So infection vector comes as a phishing mail, which has an attachment, and in that attachment it contains an embedded link, and normally this embedded link redirects to the cloud services, and which downloads to the first stage payload. So what Cloud Squirrel does? Actually, Cloud Squirrel it abuses multiple cloud platforms like JElastic platform as a service, Cloud App software as a service, Amazon AWS, and Dropbox. After abusing all these cloud services, it downloads the second stage payload, which is DES encrypted. While doing analysis, we found out it is the key for DES encrypted file is Squirrel. So that's why we named this malware as a Cloud Squirrel. So we are going to see the complete malware attack kill chain, how it is being executed on the system. So as I told you, infection vector comes as a phishing mail, and which contains an embedded link. So embedded link normally belongs to the serverless JElastic platform, which acts as a redirector and redirects to the Cloud App. And Cloud App in turn uses the AWS for its backend services, which downloads the first stage payload, which is jar file. So jar file contains multiple class file. One of the class file contains hard-coded embedded links for the next stage payload, which belongs to normally the Dropbox and one IP is there. So these Dropbox links normally connects to the one more link, and it will downloads the next stage payload, which is a DES encrypted payload files. So as I told you in last slide that key for DES encrypted payload is Squirrel. So after like decrypting this DES encrypted file, it will drops those decrypted file inside the random named folder in app data, which actually there are 4 files, and then we found out there is only one is a benign file and 3 files are clean. So I'm going to cover mainly those 3 files, what they are doing. So first file is igftray.exe. It drops actually 2 more files, that is view.exe and views.exe. What are these files doing? These are the Nearsoft tool. Everybody knows the Nearsoft tool. What are those tools? Like they will provide mainly password extractor, recovery tools, and all those tools. So with those tools, it will exfiltrate the data from the Outlook, and those data will be sent to the CNC server. So next exe used for like collecting the machine data, like operating system info, machine info, and that data also sent to the CNC server. So then third exe is used for cleanup, for complete cleanup of the Cloud Squirrel. After like receiving all that data, like exfiltrated data and machine data, CNC server reverts back to third exe, which does the cleanup and deletes the random name folder, which is there in the app data folder. So you have seen the multiple cloud apps being used in this Cloud Squirrel. Actually, Cloud Squirrel abuses multiple cloud services. So we are going to see one more example, which is short.jsrat, where single app being used multiple times for downloading the stages, multiple stages of malware. So short.js rat actually uses Windows component files, we call scriptlet files, for downloading first stage and second stage payloads. So these payloads are being executed with the help of squibbly-do technique. You might have heard of squibbly-do technique, but I'll tell you in short, what is squibbly-do technique? It is Windows native apps being used to bypass the Windows whitelisting services like Windows App Locker and all those stuffs. So I'll come back to this point with details, but after that, there are other cloud services being used like Dropbox and GitHub for like third and fourth stage payloads. So you can see in this image how squibbly-do technique being used to download the next stage payload, mshta.exe being used to download the second stage payload. So yeah, I'll explain you in next depiction as well. You'll get a clear idea how it is being used, squibbly-do technique is being used. So when user gets a Google shortened link, when he clicks, it will download the first stage payload, which is 1.sct. So 1.sct file is like registered and executed with the help of regsvr32. So once that file executed, in turns it uses mshta.exe to download the second stage payload from same cloud app services, and it will download the second stage payload. So seconds after downloading second stage payload, it is the main malicious payload which contains the next stage information of downloading what malware is being downloaded. So this is the standard syntax or pattern used by short.js rat to download different kind of malware. Like it is being it is normally downloading some banking trojan, coin miner. So Ashwin is going to cover some of those coin miners in next session. Over to you, Ashwin.
Thank you, Rushikesh. So you might have seen some examples that we have stated wherein it has used multiple cloud apps. If you go back to the earlier example of what we have stated, we have already told that only 14% of the enterprise are protecting major cloud applications that you use. For example, you have protected Dropbox, but if you have not protected the other applications through which it has transitioned itself into Dropbox, there won't be any protection in place. And the same lines, if you look into this particular example, when 1.sct was downloaded, it was benign in nature. It just had a component to download 2.sct, which is not malicious as such. And the main malicious component occurred in 2.sct. So what it will look is, when the transition goes back and forth via the same cloud app, it will again look clean in nature. So coming into the same lines, the first example was wherein cloud was used to host malwares. Now let's look into a little more complicated example where cloud has been used to use something like a command and control channel. So for this, we are giving an example of a malware that we discovered by name XBooster. It's a parasitic Monero mining campaign. We all know that crypto miners had a very big fame for the past few years. Of course, currently it has gone down, but when we know once the nonce actually comes into picture, and once 4 years also come into a timeline, again the cryptocurrency values will increase. So keeping that in mind, like with related to Monero, it's actually a parasitic Monero campaign that we had seen. We had seen close to 300 to 500 binaries with a particular malware operation, and all the binaries had a modus operandi in it. It used something called paper install and paper click. For people who don't know what is paper install and paper click, paper install is a mechanism put by the malware author to tell that whether this malware is installed in your machine. Paper click is nothing to tell that whether you have clicked that particular file and it has got infected. That's it. So this is a way that the malware author will also know like how many people have actually got infected. On the simple lines, we can say that nullcon registration simply says that this many people are registered to nullcon. The same way, the threat actors also keeps this particular picture of identifying who all have got or automatically infected. Well, this is one part of the malware. The interesting part of the malware is where it transitions itself into cloud, where it has used Amazon S3 as a downloader, and it has used Amazon EC2 as a command and control instance. Not only when you load the file in a debugger, the malware author has done a lot of interesting tactics. There are many to cover. Of course, you can look into our blogs, where we have done a detailed overview about the malware. We have drilled it up and down. We have looked into all the Monero accounts and all. But this was something that the malware author did. He was able to generate around $100,000 at that moment when we wrote, and he was able to generate 40 1 Moneros using 21 unique Monero accounts and 293 workers. We all know like why they use Monero. Monero is autonomous in nature. If at all I transfer my money to other person, the other person will not know from whom it is transferred. Bitcoin actually does it. That's why people use Monero. Just to give a context of why threat actors have used Monero. So when you load this file in a debugger, the first thing that you'll see is it will first look into something called get native system info. So after that, what will find is, it will find out whether the system is a 32-bit operating system or a 64-bit operating system. Depending upon that, what it will do is it will have a valid ID allocated for a 32-bit operating system and a 64-bit operating system, and that's how the mining operation happens in your machine on behalf of the threat actor. So to give a context about how it looks, the user visits some random website or he looks out for some latest version of Adobe software, and that's where using paper install, the file comes to his machine. From here, what happens is when he executes that binary, it drops in a file called distriblauncher.exe. And this executable does the pay-per-click model. It actually tells back the command and control server, yes, this guy is really infected, or yes, executed this piece of a malware. And from here, the transition moves into cloud. You'll see how many times Amazon is being used. Now, for the first stage payload, Amazon is used, it downloads a zip file. The zip file is password protected, which is present, the key for the password is present in the main file, okay? The password is 1 byte, okay? So using the particular password, what happens is it drops 2 executables into the machine. Now here comes one more problem. If there is a password protected file coming, does your scanner protect? No. Because again, you need to look out from all the transition from where the file is coming. Now, after it drops manager.exe and the next binary xmrig.exe, it starts the next stage operation. Let's look into the next stage operation here. Manager.exe doesn't stop there. It again goes back to Amazon S3 and downloads the next stage payload called dbupdater.exe. Now dbupdater.exe is the part which actually uses the command and control server as an exfiltration mechanism. So it again drops in a binary called dbupdater.exe, and this binary takes in all the details of your machine, like what antivirus you're using, what are the processes that are running in your machine. Why it takes what are the processes that are running in your machine is because consider that you are in a corporate and use some piece of software which is only allocated to your corporate. I can see that if at all these softwares are not present in a machine, I can infect it. This is a traditional methodology done by threat actors because your sandbox will not have the operating system or the processes that your computer has. For example, your computer will have BitLocker, but your sandbox will not have BitLocker. So this is why the threat actor takes in all the processes. So by taking all the processes, he stores it in a file called log.txt, and then he goes back to Amazon in an EC2 instance and actually uploads all this encrypted data. And of course, the important essence of this malware is to do coin mining. So it uses Stratum Pool. Stratum Pool is nothing but pool. We all use pool for cab driving, right? The same thing is related to coin miners. For example, if you need to solve a particular coin, if at all I need to solve it, I can do it individually or I can do it with a group of set of people. So that is done by using something called Stratum Pool. So using the Stratum Pool, what does it do is it does the Monero mining. So this is how the threat actor had actually used cloud, not only for downloading once, twice, thrice, use the cloud up and on for multiple services for doing it. Now, why it has used EC2 for actually uploading the logs is because it doesn't want to enable read-write access. If you do it, you can actually hack in the server. Now, we'll go into the next important aspect wherein cloud has been used to spread malware. So all these aspects wherein was the threat actor wherein he sent in malwares. Here we'll be talking about an interesting shift wherein the cloud is used to spread malware by misconfiguration done by you and even by the disconfiguration done by the cloud setup. Over to Rushikesh.
Thank you, Ashwin. So we are going to cover like malware fan out effect. Sorry. So what is we are going to tell you how malware infection is spreading through the cloud. For that purpose, we are going to see one example of malware, which is Wirlock ransomware, which is a special ransomware. Normally, it has a file infector capability as well as wormed in nature. So due to that, what happens? If you take a system, it will get infected by ransomware, Wirlock ransomware, then all the files, folders will get infected due to that. But due to worm and file infector in nature, if there is any shared folder is there, what will happen? All the files which are encrypted will got shared to the other shared folders. So what will happen? The infection will start spreading through the peer networks very rapidly. So if you see, this is a typical graph of a particular organization which contains like black dot indicates users and blue dot indicates the standard shared files. So if particular user got infected with a Virlock ransomware, then all the infection starts spreading through the complete organization, and the complete organization got infected with a Virlock ransomware, and complete fan out effect of the malware can be seen. Here we have seen how like ransomware is being used by like with the help of malware. We have seen how fan out effects seen on the cloud infrastructure. We are going to see one more example where we are going to see the exploit which is wormed in nature. For that purpose, we are going to talk about the SMB exploit, which is famously known as Eternal Blue, and it targets the open SMB ports it targets open SMB ports on the machines. So what will happen when particular user gets a mail with an attachment, and we have seen this case, like user gets an embedded link inside that mail. After clicking that embedded link file, it will executes and drops the Eternal Blue exploit. What will happen? Eternal Blue, at this point, Eternal Blue has been dropped on the system, so it is already inside your environment, and it will start targeting the open ports of the SMB drives and shared SMB machines on your environment, and start laterally spreading the infection throughout your network. But there is one more aspect to this infection. If the person who received that phishing mail or something, he shared that particular attachment to the cloud, then what will happen? Some other person who is like using same cloud services or something, or they will see that this file is shared by this initial person, and they feel like this is a clean file, and if they accesses that file, the same file, then same infection starts spreading through the network. So you can see how cloud has been used, like due to cloud, you can see how fan out effect can be seen for the different malwares. So mostly one more example is going to be covered by Ashwin. Thanks.
Okay. Yeah, thank you, Rishi. So in the earlier example that you had seen, you'd have seen one more interesting attack pattern where it has transitioned itself into cloud, and that is done via sharing your email attachments, because this is something that is done in all the enterprise currently, wherein you're sharing your email attachments towards cloud. And consider that you're working in an enterprise and you're sharing all your email attachments to cloud. Tomorrow you have left the enterprise. Okay, what will happen? The manager of the enterprise will become the owner of that particular cloud account. Okay, and that particular cloud account can be actually shared out for having some type of reading materials, etc., and so on, or it can be even synced to you because you are a part of that particular team, right? So this is actually when it transitions into a next part of a problem that is nothing but cloud phishing fan out effect. So we'll give a context of why it is important, and based on our study, we have seen 90% of enterprises falling victim to this attack in two ways, which we'll again tell, and you can also actually audit that and actually have a look. So now, how it happens? A victim is shared with a bait, and he's actually viewing it, he gets infected. That's one part of the story, which happens if at all he is not much protected, or if he's not so tech savvy, or he was not vigilant. Fine. So he has kept the file to cloud and he has left the organization. Now what happens? Some new guy comes into the organization, he tries to look into some materials, and that is where he becomes the source of viewing that particular document. And what will he think? The file is coming via some new user or the new owner who is the manager and not the other user, and the same way it is coming internally. So he will lose the context of identifying from where the file originally came in, and he will think that the main source of the file is the user who's actually sharing it to me, and that's where what will happen is he'll not know from where the file has originally come. This is one part of a problem. The second important part of a problem where all follow is default allow policy. How many of you use PDF readers? Everyone here use PDF readers. I do not need any hands for it. Many of you use Adobe PDF readers, some use Foxit for protection, etc. and so on. But none of you are protected from this particular aspect. Now what will happen? Let me give a context to you. So consider that I've visited Nalcon, I have some bills that I have to claim from my corporate. So what I'll do is I'll send an email to my finance team telling that, hey, my corporate email is not working. So please consider this bill that I'm actually sharing you via my personal email ID. This can be done by impersonation from an attacker's perspective, which is already known to you all. So this is how the email comes in. He says that the email says that, sorry for sharing this document via personal email. Can you please approve the reimbursement bill? From a threat actor's perspective, we have to be very, very clear that it has to be as trusted as possible. This is actually trusted. So what does the finance manager do? Okay, fine. This looks legit. So let me do this. Let me take this file. So again, when I open the file, let us think it is not showing me the exact bill. So what do? Okay, fine. Let me click the zoom in or zoom out. I'll do that. What happens next? It connects to Dropbox. So what does the finance guy do? Yeah, we use Dropbox for our day-to-day operations. So okay, fine. I can use Dropbox for actually downloading the attachment. Okay. So what happens here is, if you look into the corner here, it says that remember this action for all PDF documents, right? This is something that you all fall a prey for. You actually go and have a look into any document that you have visited which connects to an external website. This is how a particular bait is actually coming into picture. So now the threat actor can do multiple things. He can use this to download a benign file wherein you allow dropbox.com if you're not using it at all. And once you have allowed dropbox.com, from the second instance you'll not be alerted about it. We all know it. And this is how a malware comes into the machine and you execute the malware, and then of course the biggest disaster comes into place. Now, the biggest question. This and this. Going back. So here if you see, it says that it connects to dropbox.com, but it doesn't show the full URL path of what is actually being hosted in Dropbox. But in the earlier versions of PDF readers, you were actually shown it. In the current version of PDF readers, you are not shown it. You are only shown through which domain the particular app is getting connected. And if you're trusting the domain, you're trusting any file that the file is getting downloaded from it. And if you trust a URL shortener, that's it. You're putting your system to a bigger compromise. So this is an example of telling, like with a URL shortener, like tiny URL, how the file actually transitions in terms of connecting to an external link in an older version of Adobe Reader and a newer version of Adobe Reader. We all use the latest updates because we want to stay protected, but this is a gap. If you allow tiny URL, what will happen is any future alerts that goes to tiny URL, you'll not be alerted. Same thing is with Foxit Reader also, which is as an example. Now, this is a question that I want to ask. How many of you have heard something called Trust Manager in PDF documents? Any hands? 1, 2. How many of you have actually audited the Trust Manager? Good. So if you have audited the Trust Manager, if you go into, this will be there in almost all the PDF documents, something called Trust Manager. You will see something called internet access from PDF files outside the web browser. This is something that you need to audit, and if you see, you would have allowed tons of websites because you would have just clicked OK. And go there and see what are all the URLs that are there. And from the future, this is a recommendation that we are trying to tell, please don't click the default allow policy. Please see whether you are really connecting to it, whether you really want it, and then only connect to the particular PDF reader, because this is how attacks can take place. I can just launch a decoy document with a clean file, and that file is not malicious, but you have allowed my domain. When you have allowed my domain, I can keep on launching multiple malicious files from that particular domain. This is how attacks are currently taking place, and this is a very, very important attack vector component that is happening in terms of all the attacks. Now, this is something with related to the user. He gets a file, he gets infected, and he's trying to sharing it to multiple people. Now let's get into another interesting aspect. Consider that the cloud app itself is a mechanism to spread malware. How? Based on how its nature is. We all know Salesforce. Salesforce is nothing like a CRM software. CRM is nothing but a cloud relationship management software, which is used for multiple operations. The same Salesforce application or account is used by a vendor, partner, and of course a business owner also. So now we found an interesting malware which we have discovered and we have contacted Salesforce on. It is related to a banking Trojan, and this is a malware campaign that spreads via a Salesforce component called Pardot. Pardot is actually a storage service used by Salesforce. We found 12 unique URLs at a particular day from an account. At this moment, we don't want to say whether it's a compromised account or a hacked account, but it is spread from an account. And all these files were spreading something like an infected zip files. The infected zip files contain an attachment called readme.link. And the other thing that you'll have to keep in mind is in all your Windows machines, you would have disabled something called enable known file extensions. So you'll only see it as readme. you'll not see that readme.link to at least be suspicious. So this is also something that you can keep in mind. Enable all your known file extensions in your Windows machines. So this, coming back to this malware, this file contained a link file which actually connected to Google Docs to download the next stage payload. Now, Google service is also not protected. Not any service can give you a comprehensive 360, 100% detection at any point of time. So from this Google Docs, a malware also got downloaded to the machine. So this is a small snippet of how this malware looked. It had a link file, and the link file had a VB script which actually invoked a VB script via a link file. And what had happened there is, this particular VB script contained a URL through which the next stage payload was downloaded to the machine, which is nothing but a trickbot Trojan. Now, just to give an essence of how this looked in terms of a depiction. One, an infected victim. So let's take into context that it might be compromised, or the infected victim's account might have been hacked. So through that, what happens is the threat actor, in fact, in case he wants to get a malware to your network, or in case he wants to target you, he need not go via targeted email, he need not go via any aspect. What he can do is he can only look into the services that you use. So what he'll do is he'll go into the particular pad.crm account and he'll upload the malicious file. So now the malicious file has transitioned itself from pad.crm to all the users using pad.crm in that network, who are the partners, users, and the vendors. And here, as I already told, if you have disabled the known file extensions, you'll only see it as readme print doc. So consider I've executed it. Now what happens here? Once I've executed, it connects to Google Docs. Google Docs is something that was used by the users of those enterprise for their day-to-day operations. And via Google Docs, trickbot Trojan has come into the machine, and at that moment when we are analyzing, the malware had no detection in across VirusTotal, which had multiple antivirus engines, and it was termed to be clean also. And just to state this example, you see here, cloud has now become a platform to actually spread malware across the partners, users, and vendors. And then actually what has happened is it has actually harvested the credentials of the banking websites that the victim has visited. So this is an important aspect to tell you, wherein cloud has turned out to be an important arena which is used as a spreading mechanism across its partners, users, and vendors. So in earlier stages, we had to do a reconnaissance, identify how to get into a particular network, how to infect a particular user. But here, the threat actor simply looks into the trusted aspect. Okay, this guy trusts Salesforce. Let me put a malware in Salesforce. That's where I infect all these people. And now we'll go into an interesting aspect wherein cloud is a platform to host crimeware as a service. Over to Rushikesh.
Thank you, Ashwin. So cybercrime is evolving nowadays. Not nowadays, from some time it has been evolving. So these cyber criminals become very highly organized and in commercial form. So what is happening? So all the cyber criminals are moving to the next stage of their phase, where they developed a different kind of cloud-based services, which we called as cybercrime as a service. And they have been providing different services to the users, criminals, wannabe hackers. So all those people get all these services at very nominal prices. If you see some of the images we have collected, you can see the ransomware as a service is provided by some of the vendors, and that those are very cheap at price. And they are also providing support for such services as well. We have collected some snapshots from the dark web. If you search, you will also get it. So we are going to cover one service, which is phishing as a service. We have been observing that service from last 2 to 3 years, and the services keep on evolving. So this service has been hosted on multiple cloud services like Amazon, Evernote, and now. So I'll come back to this point, why it has been hosted on multiple cloud services. But going ahead, phishing page of Hacksheet is hosted on PalmClone, which is a file sharing app, and the phishing pages which provided by Hacksheet are SSL certified. So these phishing pages are designed to mimic the popular login pages of the service providers like Microsoft OneDrive, Google Docs, Dropbox, and DocuSigns. And when particular victim accesses these phishing pages, what will happen? They will try to access the page, and after accessing the page, they feel like, as Ashwin told initially, it looks like clean due to SSL certificate and all those stuff. They will put the credentials. After putting the credential, those credential is recorded via WebSockets, and those so if you go to the more details, we try to access some of his, try to register and went to his pages, and we saw multiple services are provided by these ransomware or any phishing services. So Hacksheet will provide the standard templates for every phishing pages. You can go and just click generate the page, and they will generate the phishing page for particular site. And you can just, user can download those services or templates and send it to the victim, and those people can easily fooled, and they can just they can just write their credential to that pages. And there is one more point. These sites and these services are quite, you can say it's very very tight and very properly designed. You can log into their page, you can see how many pages has accessed that phishing page, how many people has entered the credential. So all services are very standardized pattern they have collected, and all these services are very cheap at price. So over to Ashwin to cover more context.
Okay. So if you see here, there's one more interesting aspect that Rushikesh told. So what happened earlier was it was hosted in multiple platforms and services like Amazon, Even Now, and Node. So what we did is we found it hosted in Amazon. So because of the shared responsibility model, the user has to take care of his own enterprise. So the threat actor was taking care of his own enterprise. So what we'll have to do is, we can't take down Amazon. So we went down to Amazon and said that, hey, we found some attack elements hosted in your website or your infrastructure, please take it down. So after a week's period of time, Amazon took it down. Then again, we were surprised after a week wherein this particular website was again up. And when we looked into where it has resolved, it resolved into another website called Even Node. It's again a platform as a service. We again contacted Even Node, and we took it out from that particular service. Then again what had happened is it had again transitioned into a service called Now. So this is an example to tell you that threat actors right now have got an important aspect. You have your code, you have your infrastructure, just take it to a different cloud service platform. That's it. So taking down is also a bigger challenge in terms of the attacks. Now, the last aspect, so we are coming into the close of the section in terms of explaining on what all we have covered. We have covered multiple attack patterns. In terms of a traditional kill chain is nothing but a process of how an attack takes place. You have something called reconnaissance, you have something called weaponization, delivery, exploitation, installation, callback, and persistence. Now, when it transitions itself into cloud, in terms of the attack patterns that we have explained, what has happened? One, the cloud security posture that you have explained earlier, that was abused by threat actors. And because of the cloud security posture and because of the problems, what they have done is they've used the tactics, techniques, and procedures in terms of using those attack patterns for infecting users. And if you have seen all the attacks, they've used valid SSL powered and they've used valid domains and certificates with related to top tier vendors to download malwares. And in exploitation phase, we have seen that they have abused collaboration, they have abused something called sync, and created fan-out effects for actually creating a different propagation vector or the secondary propagation vector. And with terms of installation, we have seen that they have used popular cloud applications that the users use in their enterprise, and they have actually put the payloads also in the popular cloud applications. And with terms of the callback, it has actually used it for staged downloaders for downloading the next stage payloads, and it has even used it as a command and control server. And with persistence, it has used that for data exfiltration that we have covered in our earlier cases, and has even used it for lateral movement. You can use it at a later point of time once the presentation is shared to you. Once you click in these particular aspects, it will redirect you into the aspect of what we have covered. Now, we're coming into the end. We'll first look into what are the commonalities of the attacks that we have seen. One, users have trusted cloud services, which is known to us for sure. And the next part is users trust cloud services shared by co-workers or partners. That's also another aspect of malware coming in. And the biggest problem of the commonalities that we have seen is taking down a cloud app is now a biggest problem. You can't do it. Okay. There are some challenges in terms of taking down a cloud app because you use it for your day-to-day operations. And the same lines, blocking it is also tough. So we will come up with some generic recommendations of what you can do. First, make sure that you have a holistic, homogeneous protection across all services you use. HTTP, HTTPS, cloud, and other cloud services also that you use. Inspect your cloud traffic. Next thing is block services that you don't use. Consider that you don't use Google Sites, block it. That's an important aspect to at least protect you from latest threats. Of course, that's not a recommended aspect, but if you're not using a service, it is better that you block it because you're not auditing it at all. And the other aspect is block unsanctioned instances that you use it in your enterprise. For example, I'm using abc.dropbox.com in my corporate instance for my day-to-day operations, and a traffic is coming via 123.dropbox.com via a different instance. We can actually discrete a sanctioned instance and an unsanctioned instance and actually block in the particular malware. So this is how the recommendations. We are short of time. So you can actually view in our blog, which covers a lot of aspects of malware. There's something called the Netscope threat report also, which you can look into. And I'm free to take in questions if at all I have time now, or we'll take it offline also. Thank you.